welcome back to proglangcast. This is our episode 3, talking about a comparison of a different style of introductory programming for a given language, which we are now calling Bye Hello World. Last week we were calling it Goodbye Hello World, but we've changed. And this today we are talking about a version of this program in APL, just to give you a rehash of the fundamental nature of this program. The Hello World program, while it is reasonable for a novice programmer to have some introduction to a language that just simply outputs the words Hello World, the Hello World program is not, or the Hello World example rather, is not very valuable to an experienced developer that is looking at a new language. So we sat down to come up with a different version of an introductory program that gave some basic understanding of what the language could do. So in that thinking, the Bye Hello World example attempts to demonstrate command line parameters, prompting the user for input, doing validation of the input, conditional branching based on whatever the input is, and iteration of repeated execution until the condition is met. So today we are looking, last week we looked at PHP in comparison to C. Today we're going to be looking at APL. And so you have written this application in APL, and we'll talk about again in a minute, but talk to us a little bit for the moment about what APL is.
Okay. I'm trying to, I struggle with Discord here. I'm trying to figure out how to get both of our pictures at the same time, both of our faces here. Why do I have difficulty with this? There we go. I don't know. It's like a double click or triple click or something.
Well, it's because you're not sharing your screen.
Not yet. So I'm going to go ahead and share the screen. You see the screen, right? I'm sharing it. So I'm now got the screen over here. Okay. So APL, a little bit of history, actually. Let's go back to our faces. So APL was actually the first programming language I ever coded anything in when I was 8 years old. I didn't do a lot. I didn't really know much I could do. I was interested in pictures and games I was drawing at the time. And I really actually the first learning I did was at the community college on the old Tektronix, green vector screen things. I was trying to make it draw pictures, and the guys working there were deaf guys, programmers, and they were showing me how to program in APL. So I kind of learned how to program a little bit in APL from deaf guys at a community college. But you have history with APL too.
Well, yes, I started programming in it shortly after you did, but it was more or less the same thing. Well, when I was working at Aerospace, I wrote a database manager system that I called DIPS, and that was written in APL. That was a challenge. That was the language I had to work with back then. So that would be the only reason that I did it. So that's been a while though. I haven't seen APL in quite a while. And my understanding is APL stands for a programming language.
In fact, I still have in the books, and I think they're in the US. I live in Portugal now, but I still have the original book, a programming language. It's like black with the red letters. And
you still have that?
I have it. I kept it. There's only a few books that I kept. I threw out most of my old C++ books. I mean, who knew he uses actual physical books anymore? But I'm like, this is historical. I'm going to keep it. But the reason I say that is you've written more code than I have. Like I wrote a few little things, little games. I made like a little skateboard game, text mode and stuff because I was into skateboards. But I quickly moved on to BASIC, and then I moved on to assembly with the PC, and I never went back. And so I kind of have this, as a kid, I loved it. I love what people call hieroglyphics, because as a kid, it's like, oh, it's a secret code that only I can understand, right? It's like, it's fun, right? It's fun as a kid. And I was into art and I was into drawing and stuff. But you've written an entire system in it. So
yeah, I never went that deep. When we decided to do this in APL, I went to see if I could find any copies of any code, but back then, I didn't have any electronic copies of it because it was classified work. So I had to, I couldn't take anything offsite. So I don't have any examples of anything I did in APL in the past. And I'll bet you don't either. Do you have any examples? Do you still have any
You know what?
examples of that old
No,
code?
I've tried to dig up some of the really old base games I wrote in BASIC. I actually wrote some of the first games for the IBM PC when it first came out. I was very young.
Yeah,
They were lame. They were just copies of other people. Like I had a variation on Snake and a variation on Breakout and a variation on Star Wars TIE Fighter game.
I
Um,
remember. Yeah,
I've tried to find that code and I've tried to actually run them in some kind of like weird downloadable basic
yeah.
interpreter, but I got nothing in APL. Like there was at the time, there was these were on these little magnetic cassette tapes, right? Because it was on like
Hmm.
the 5110, and at the community college, it was like a 360 plugged into a Tektronix. What is it, a 440, something like that anyway. And I had no access to it, and I wasn't doing punch cards. I mean, I didn't know any of that. I just
Oh my God, you're dating us terribly now.
yeah. Well, I'm not gonna put dates
Some of the
or
audience here is not going to ever have heard of punch
I'm
cards or
fine with
mag
that. I'm
tapes.
fine with that. Let's not dox each other in terms of that. People can do research if they want to see how far back we go. But
All
yeah.
right, before we go on next, I want to make one comment about last week's video. I made a kind of a tongue-in-cheek comment about all good programmers steal code from other good programmers,
Oh,
and I didn't want to advocate code theft. To
code
clarify
theft.
that, all the code that we are presenting here is covered under the Mozilla Public License version 2,
Yeah,
which means you guys can do anything you want with it. But
of
if you
course.
create any derivative work, you have to make the source code available to your customers. It doesn't have to be your modified source code, just anything we have produced here. So I absolutely advocate adhering to whatever licensing requirements
Oh,
are
okay.
under software that you might take from someone else. All I meant last week was, hey, you got a good programmer, you find a guy who says, I don't give a damn what you do with my code, and his code looks great. Don't insist on writing your own. Use his
Okay.
or hers. If it's better, it's better. Don't get emotional about
Well,
it.
it's
That's the
very
only thing
legal
I
of
meant
you.
by.
That's good. That's good. Very,
Well,
very
I don't want
being
to
appropriate.
advocate theft out of respect for my fellow programmers. I mean, yeah, I've gotten so much help from Stack Overflow and all kinds
Well,
of other
don't
sources
worry
on the
about
internet.
that. The GPT funnels are sucking everything off the internet they can find. License,
I
damn the
know
licenses they
they
had,
are.
and
License be damned,
license
right?
be
Yeah,
damned. Exactly. Well, actually, okay. So let me slide the screen over. You can see the screen, right? I've set up
yeah.
OBS so it's a little bit clearer here. So it's interesting you bring this up because the version of APL I decided to use for a Bye Bye Hello World is, and we've renamed it as you mentioned there. So it's now, go to the top here. We can see, I think we've updated everything. Bye Bye Hello World. Here's your nice intro.
Mhm.
There's only a few open source versions of APL, one of which is GNU APL. It's been around a while, and I was able to successfully build it from source. So I incorporated this, but it is not considered the leading edge APL. The leading edge APL is from a company called Dialog. In fact, yeah, you can see here, this Try APL is an online website that allows you to enter commands and test out your APL and try it out. It's even got all the little symbols so you don't have to type them in. But it comes from a company called Dialog. And what's interesting for Dialog, notice how it says you can download it for free, but this is not open source. It has its proprietary code, it has its own license. They say here, yeah, like you won't make copies, you won't give it to anyone, and you've got to go through the process of downloading. It's some kind of free trial. And this company, though, is the company that is on the leading edge of APL development, as it seems. I listen to a Raycast a lot, and I've been following, they talk about this a lot. A lot of the guys there work for Dialog or have worked for Dialog in the past. And so the most advanced APL is coming from Dialog. It's the most feature rich. It's got a lot of the most modern developments of APL, but it isn't open source. So I decided not to use it in this case. And I did run into some issues with things that GNU doesn't do well, that Dialog
Well,
does better.
let me ask you a
Yeah.
question. Just a just a side note here. Did you get an impression, or do you have some knowledge about what the target audience is of this version of APL Dialog? I mean, I look at it and think to myself, my God, I remember coding in it all of those years ago. I hate these symbols. I mean, I don't want to have to deal with these symbols. I mean, I understand you can do a lot in little code, but I'm looking at what you've written, for instance, and again, the word hieroglyphics comes to mind. So I'm curious, what is the target market or target audience? Is this just an intellectual exercise for these people, or is there a commercial market for it?
Oh, there's a very large commercial market that's been around since the beginning. It seems to thrive. And now I'm paraphrasing things that I've heard and listened to. Again, a lot of the Arraycast, I've listened to every episode. They've been running for a couple of years. So there's a lot of information there. It's a great podcast. I highly recommend it to people. Connor Hoekstra is the host. But apparently APL thrives in the world of finance. How exactly they use it, I'm not sure, but it's alive, it thrives. Dialogue is a going business, and they make money selling their implementation of the language and then providing probably consulting and services, and they continue to work on optimizing and tuning and providing implementations in different environments. So, I mean, it's too much. This is a very deep topic. In fact, all of APL and array
Sure.
languages in general is a very deep topic. So I think
Let's
we just scratched the
let's make a
surface
note.
here.
Let's make a note to include a link to the fellow you were talking about, Hoekstra. Is that his name?
Connor Hoekstra, yeah, he does
Connor
he
Hoekstra.
does
Let's
code
make
report.
sure we provide a link to
Yeah.
some of his work and maybe to dialogue as well in this.
Arraycast is great. But to address your question specifically about hieroglyphics, so I think you could almost divide the programming world, the world of programmers, into two buckets. And I'm not so much I don't like categories and buckets and putting people in them, but if you wanted to, you could say those that find symbolic symbols, glyphs comfortable and even like them, and those that really don't. Those that are like really uncomfortable with the idea of having to program without using, in particular, English words for most of stuff. I have a particular bias against the fact that the programming world is so locked into English. Unless you were in China, I guarantee you, if we're in China, it's all going to be in kanji and stuff like that. It kind of like divides the programming world. But there is a group of people, clearly from the APL generation and on, and in modern, and you hear a lot about this in Arraycast, who not only are comfortable with these symbols, but claim and feel that there was an advantage to that. And the advantage that they mostly claim, and I'll summarize this very shortly, if you will, goes all the way back to Ken Iverson, the creator of APL's original write-up that he said, notation is a tool of thought. The idea is that, for example, if you're doing mathematics, imagine if when you're doing math as a kid and you're learning 1 + 2 and all this sort of stuff, and instead of the plus and the minus, you had to spell out the word plus, and you had to spell out the word minus, and you had to spell out the word divide and all this sort of stuff. And there's a lot of research in the area of learning that kind of says, these simple notations, it's a tool of thought. It makes it easier for us to act once you get familiar with it. Once you're familiar with the notation, just like when we were born, we weren't familiar with the whatever alphabet of whatever language we speak.
Yeah.
And so there's a difference between the discomfort of unfamiliarity and the discomfort of familiarity, but I don't like it. And I think a lot of people with APL, it's like, well, it's unfamiliar. I'm so used to programming with words, and yeah, there's braces here and there, but mostly it's going to, I can read it like a language. I can hear what it's saying, and I'm used to that.
Right.
But this whole idea of notation as a tool of thought, Ken Iverson basically said, well, look, for math, if you do math, it would be crazy to have words for all these things in math. And if you get into more sophisticated math, that mathematicians do, where you have all kinds of Greek symbols, right? They couldn't work as quickly. Actually, his argument is you're thinking at a higher level or a level in which it affects the way that you think in a better way, and you can kind of rise. I don't know what to say. I'm doing a poor job of this. Stop me at any point.
Well, it was you struck me at one point when you talked about what would be having to type out plus or having to type out divide. And anybody who's familiar with a stack-based lexer, like for a programmable calculator or for working in PostScript or anything like that, those are all. I mean, they're not divide. They have div and mul and flu, and they're all just coded out because it's all just English letters. Don't have any of the symbols to work with. So, but I agree with your thinking about familiarity. I mean, largely, if I look at what you did here, my first reaction, which was always my first reaction with APL, was kind of like, wow, that's a lot of symbols, and I got to figure out where they are on the keyboard. And it's not immediately readable, whereas the languages are based on like the C Lexer or the basic Lexer, especially that environment, which is all just written out as a language. It's certainly easier to get immediately familiar with it. In fact, years ago, a friend of mine had looked at a Pascal program that I wrote. He was not a software developer at all, and he said, Steve, I don't have any idea what you do, but I can understand what this thing's doing just by reading it. And obviously, you can't do that with a symbol-based language like APL. So anyway, let's move forward and take a look at the code that you've written here.
Well, let me ask you actually a quick question. Do you recognize any of these? Do you remember any of these symbols? Any of them?
The quote quad.
The quote
I think
quad,
we used
yeah.
to call it.
Exactly. That's the one
it's
thing
the
I
console,
remember. Yeah,
right?
the quote quad and the quad and the quote quad. But I remember the quote quad. Most of the rest of it, I don't remember any of the rest of it. But that's the one that stuck
one of
out.
the reasons. One of the reasons I remember the quote quad is like a lot of symbols in APL, you took two keystrokes. You had to put in the quad and backspace and do the quote.
Yeah. Well, that's the other challenge of APL. And I think actually the greatest barrier of entry, in my opinion, is not the unfamiliarity of the symbols, but the difficulty of the keyboard. Because when you and I were programming APL, we had APL keyboards.
Yes, we did.
The computers we had were designed for APL, and they actually had that. You literally would go shift, and you'd have the omega, and you'd have the quote quad, and you'd have it all. So, so we don't have that here, and it's quite a bit of setup. Now I'm in a Mac environment. You
mentioned the kanji character sets before. You can imagine if you were coding in a kanji language like that it would be a very different keyboard.
If it's a keyboard at all. It'd be really interesting to be in China and sit next to somebody or just somebody Chinese who programs in Chinese and see how they do it. Also, they're top to bottom, they're not left to right. I mean, it would be a really interesting experience. I would like to go through that.
I'd be curious to see it myself. I've never seen anything written in a kanji-based language.
Now, I have to be honest. So let me just overview by saying I did two versions here. I did APL using GNU APL. This is GNU APL, and I built it from source, and it builds fine on Mac OS, the latest one. It also builds under WSL, and the run script will actually automatically run it if it's not installed. So it will automatically download it and just download it locally and run it locally, which is kind of nice. It does that. But if it finds it, if it's in the path, which right now, because I kind of installed it, it's in my path, so I don't have to build. I can just say APL, and there we go. And it's an interactive environment.
You used GNU APL, not the Dialog.
Yes. This is not Dialog. This is GNU. So this is open source under the GPL. I think you can see there. Yeah, GNU public license. So our code is not GPL. Our code is MPL. So people can do what they want with that. I did put the little headers in there. But I want to mention that last week I said, we were planning on still doing 2 languages per week. We think that's too much now. I said I was going to go.
Right. Okay. So we're going to be doing 1 language per week. So this week you're writing an APL. I'm going to be asking you about the APL. Next week we're going to skip a week next week, or we'll have to do it midweek next week.
Double it. Yeah.
Yeah, and we're going to be doing F# next week.
Yeah, I'm looking forward to seeing you do X# because I think it'll be fun. I think it'll be great, and
we'll see. Never done it before, so we'll find
out. But I decided not to do J. I was having a lot of trouble getting a source build of J. I could have downloaded it, and I could have installed it, but I tried to go through the source build, and unfortunately, it uses NASM, some specialized assembler, which required auto-config, and the auto-configs weren't the right versions, and I just went down this whole rabbit hole, and I'm like, you know what? I'm going to switch to BQN. Now, BQN is an array language similar to APL, created by
Well, let me back up a minute. Yeah. You're saying that you actually wrote BQN because the APL was just too difficult to get. Oh no, because of J. You were talking about J. The reason you didn't do it in J?
Yeah. I didn't do it in J because it was too difficult to build the J, and I didn't take the time to just download it.
Okay, well let's talk about the APL and the BQN.
Yeah. And
Is similar to
BQN is
APL.
very similar to APL, but it's a newer
Right.
language. It's only been around a couple years. Marshall Lochbaum, the creator, Zyma, who does some of the implementations. You're going to see that it's very similar, but there are some differences. Anyway, let's go through the APL version.
And there's a lot less of the special characters. That's the one thing I'm
No,
noticing. I've never
there's
looked
just
at
as many, but
Really?
I didn't use as many of them. But it has a large vocabulary of special characters, and some of them are the same, some of them are different. But we'll go over that in a second.
Okay.
There are two copies in here. There's just the APL, and there's the debug version. And the debug version, I inserted some kind of printf sandwiches in here to help me as I was struggling with getting this working. And I cheated and put a copy of the whole keyboard in here because I didn't install a key map. Actually, I do have the Vim syntax parsing, as you can see, but there's a key map here. And actually, I don't know if, let me see if there's a help APL. No, there isn't. But in BQN, I can enter the keys directly, but let's get out of that. So what I would do is I would literally just kind of cut and paste the symbols when I needed them.
Okay.
Like
Okay. Well, let's talk about specifics. The Bye Hello
yeah,
application. Let's see how that one gets started. Like you've got this at the top here. You've got your describe.
well,
and how-
I'm just gonna run it. Let's just do a run here. So let's
Okay.
just say run. Now this is a little error coming from GNU APL. Something about it doesn't like the way it was built, but still pretty much works.
Okay.
We're going to put in the wrong thing. Now notice that it's not echoing the characters. This is a gap. I haven't figured out how to get it to echo the input characters.
Interesting. Okay.
Yeah, so echoing is not happening. But if I put, let's put 3 in there, and it does the countdown. I can also pass command line parameter. So I can say 5. There we go. And I can also pass an incorrect command line parameter, bud. And it says, oh, invalid. So I think we met.
Okay, well, you got your invalid countdown FUD there.
Yeah, because
So-
that was an invalid at the argument. So it says, yeah, I don't like that. Please enter something different. So I think we've matched the spec, except for we're not seeing characters echoed when I actually
As
enter
you
the
type
countdown.
them. Right.
So, oh, and there is one change from last week. You said that 0 wasn't allowed. I haven't run the C. I guess I could run the C version, but if I actually do 0, if I say run 0, it is valid. It just doesn't do a countdown. It just immediately goes, okay, we're out of here.
Okay, so that'll be something I'll remember for next week. We'll do the F# version. We'll allow
Actually,
0.
let's see what happens if we do the C version and we say run 0. See if it allows it. Yeah, 0 is okay. It won't count down. If we do 3, it does 3, 2, 1.
Yeah, the PHP version won't.
Okay, so that's a little bit different. I mean, I don't care which way we do it. I thought 0 was okay though. It seemed like it worked fine.
No, you're absolutely right. I think that makes sense. It didn't occur to me at the time.
So
But,
let's
definitely should
take a
put
look.
that in there.
Let me just walk through it, and we can compare it. If you're good with that, we can compare it with the C version on the left. So, and then maybe if we have time, we'll talk about BQN. I did the BQN as just kind of a bonus, right? What do we call it in school? What do we call it when you do more than you're assigned? Extra credit.
For credit, right?
Okay. So
I had another word for it, but it's not appropriate here.
So
Okay.
the first thing we notice is the number of lines of code. Now, lines is arbitrary because you can pack things together on one line and, do you count a closing brace on a line by itself, a line? But if you just look at the overall wordage, characterage, yeah, it's less. It's maybe half, right? Now, there's a big difference here. C is a statically compiled language. It's very minimal in terms of what it comes with, right? There's a standard library. You can see that. And when I use the standard library, I have to include the things I'm going to use. APL is a dynamic interpreted language, and it's expected to actually run in an interpreter. So I'm running it in a script form, but normally if I start up APL, I immediately get into a REPL, right? a read, evaluate, print loop, right? That's what we call REPLs. But APL is one of the original REPLs. I mean, when you and I programmed in APL, you would start APL and you'd be in this workspace and you'd be doing everything in this workspace. So it's actually
the basic interpreter back then too was the same way.
Yeah, they're much more than REPLs, right? REPL, I think, is a term we tend to use more for kind of lightweight things on top of current modern language development. But APL was a very rich, workspace environment. Smalltalk is like that. Lisp is like that. So a lot of these older languages were expected to be run, especially if they're interpreted, right? So if we just type in APL here, but when we actually use the run script, it's just invoking it with execute this file and then bail out. But one of the things you're going to notice is in order to bail out, I actually have to include the off command at the very end. Otherwise, it stays in the interpretive environment. And off is the way we get out of here. That's how we actually exit in APL.
Okay, well, let's talk specifically about how the program starts. Because I'm very curious. Like, can you show the C again? Yeah. So you see on the left side we have our main. Check our command line parameters, and we check to see if that's valid, and if it is, then we drop down into our while loop and we start printing. Now, looking at your APL version in the middle here, wow. So talk about how that translates what you did in the first part of main translates in this first part of the code here.
Okay, so there's that so. I've got to get rid of my so's. Sorry, I'm just bringing the BQN up here because we'll see a little bit of a difference. Right. So in C++, we have the main declaration at the top, required for any standalone program. The arguments are provided, and then it immediately starts executing whatever statements you have following that. Right. And in the C program, I decided a little differently. You did two versions in PHP, one where you made a separate function. In C, I did not make any separate functions for any of these statements, right? It just literally sequentially executes one statement after the next in a straight sequence, more like a script, and then it's done. So there's only a main function. There's no other functions. In the APL version, I didn't have the option to do that because of either my ignorance, most likely, or just a limitation of GNU APL. That in order to do any of this branching logic, where there's an if condition and you branch to a different place, I had to wrap that into a function. So the very beginning is actually a function definition. So from where we see the get count, that's a function definition, and then I start executing that function, and then the rest is a sequence of commands. So I had to make this a function. I wanted not to. I wanted it to be more like the C, where you don't require a main. Okay. So this is
actually. So if I'm reading this correctly, then what it's doing is it's checking to see if there's a command line.
We're losing you on audio a little bit. You're cutting out a little bit. I don't know why.
Okay. How's it sound? Do I sound okay now?
Yeah, there were just a couple dropouts. Yeah, okay. I'm sorry. Just repeat what you were saying again.
Go back to the code.
Yeah.
There we go. So the get count function here looks to, without understanding any of the symbolic, looks to me like it's checking to see if there's a command line. If there is, and it skips over the input label, goes straight to the check label to validate. The validate routine down there at check is then performing the validation. It appears to be making sure that the input is all digits. If it fails that, then it does the invalid countdown, goes back to input where it will ask for the countdown. But it appears to be that get count the first time will be checking to see if there's a command line argument. So you come down here and you do get count. You do world hello. Oh, I see. So what you're saying is you wrote a function, but this function is essentially the whole process of getting the input and making sure it's valid before you go through your iteration and printing to the console.
That's right. It only gets called. It only gets executed once, And if you look to
Right.
the right, BQN, I didn't have to do that. So the BQN is actually closer to the C. There's no separately declared function. It literally has its control structures, its while loop, as part of the linear sequence. And the reason is I couldn't figure out. So what's weird about APL is it doesn't have fors, it doesn't have whiles, it doesn't really have an if. It has an if statement, sort of. That's what this arrow is. But
Hmm.
I don't know if you remember going all the way back. If relies on branching to labels, to lines. So this is essentially a go-to statement. So we're back in
Yeah.
the world of go-tos here, rather than um, block delineated control flow, right? So in C, it's block delineated control flow, right? There are no go-tos. There's no, this is back in the day, we used to distinguish between structured programming and unstructured programming. In an unstructured programming languages like BASIC, you had go-to statements and go
Yeah.
substatements, and you would tell the program, go here, go back there, and go anywhere,
Hmm.
and you could jump all over the place. And that's the way it is in assembly as well. In assembly,
Yeah.
it's unstructured, and then structured programming was, well, we're not going to do that because go-to considered harmful. But you're looking at APL, and there's a go-to. So let me just go ahead and walk through it as you said. So the program actually essentially starts here on line 20, and it's going to call the get count function. So this is a function declaration. This little upside down delta symbol says it's like an inverted delta. I was gonna look up. Sorry, I'm gonna bring this down so we're not blocking the screen. I don't remember the name of this particular symbol. The GNU APL has a different name for it, but it's the function declarative symbol. So it's an upside
Okay.
down triangle. It's then the
That's
return
the
value.
delta, isn't it?
What's that?
Isn't that the delta?
Well, it's an upside down delta. So a delta is the
It's an
triangle
upside down
goes.
triangle, but I was pretty sure we used to call that the delta when we were coding in this.
The
Maybe I'm
Greek,
wrong.
I think the Greek letter delta. Pretty sure it's the other way. The point's at the top. This is point at the bottom, so it's an inverted delta. And so we got this undelta.
Right.
Z is
Okay.
just a symbol to say this is the return value, and this you could call it any letter you want, but the convention is if you look at examples, it's always Z. The name of the
Right.
function. Then this left arrow is assignment. So I'm assigning get count as the function to a function that returns Z. So it's almost kind of like C in the sense of main is declared by saying the return type first, where we say int and then name of a function. Here we say, okay, I'm returning something untyped, but I'm giving it a name. Because if this was not going to return a value, it would be just like that. I'm sorry. Yeah, there wouldn't be an
undelta
arrow.
there.
That would say I'm not returning a value. This says I'm returning a value. And then also, if it's taking any arguments, there would be arguments here, but this one's not going to take any arguments. And then the semicolon then afterwards designates any local variables. This is to avoid any variable assignments polluting the global namespace. So I could get rid of this semicolon C, but then everywhere you see the assignments to C, this would be setting a global variable C at the program level. So in this case,
Okay.
I'm just trying to keep the global pollution down, and I would have to declare these. Now notice at APL, these are all untyped. APL is a weakly typed, it's a dynamically typed and a weakly typed language. Internally, we have strings, we have numbers, but it's going to automatically figure that out and convert and do implicit conversions or fail where necessary. And the programmers
Can
never.
you talk? Could you? I'm sorry to interrupt. Can you talk a little bit about that first? Because I'm very curious as to how, like, a comparison between a C Lexer style language and this APL Lexer. How does that translate? Like, I'm looking at the C, and then you have the left pointing arrow, which is assigning to C, and then what looks like a comma and a little like a
It's called
sort of a half of
shoe.
an
Yeah, it's called
half of an oval. I
Yeah.
mean, it can just talk about the symbols in that line and what they mean.
Okay, so one of the first things to know is that APL reads, it evaluates from right to left, not from left to right. So the evaluation begins at the end of each line, going
That
one
looks like it's
symbol at a time. So actually the assignment to C happens last, which is
happens last.
actually true in C as well, right? If you say this equals, it's going to evaluate the expression.
Right, it's going to evaluate the right-hand side.
But the right-hand side of the equals, it's like over here where we say, for example, countdown equals stir to L. It is going to evaluate the right side, but it's going to start at the right side of the equals, and it's going to start evaluating left to right. And it's only going to nest in where there are parentheses, right? So if we have parentheses within parentheses. Whereas APL is actually going to start the entire evaluation from the end of the right side of the line. So the first thing it does is quad arg. Now, quad arg is specific to GNU APL. I did not find it in dialog, although I didn't try to run this in dialog. But this provides a string, which is the entire command line. It actually includes the arg0 that we would see in C. This comes in as a single. Actually, I'm sorry, it's not a string; it's an array. It's an array. It's an array of strings. This actually comes in as an array of strings. And in fact, I wonder if we can.
And it appears. Is that what that one is indicating? The first element of that array.
No.
I mean, how is it? Because you've got 3 1s there. I'm looking at it and trying to.
So let me just go ahead and read this from right to left, and then I guess I'll go walk back and explain it. Okay, so it gets command line args, which is a list of strings. It's an array of strings. This little guy, it's called the right operator, which is also identity. This is a way to prevent. I'm trying to remember why I used that here. I don't think that was even necessary. Anyway, I'll come back to that. You can ignore that for the time being. Identity just basically says repeat yourself. This is just repeat myself. This entire set of characters between the braces, also known as curly braces, is what they call a defense. It's a direct function. This is essentially a function without a name. So it's an anonymous function, also known as a lambda in other languages. But it's a way of saying this argument is going to be passed to this entire function. And I'm going to take
the argument being the array itself.
Yes, this entire array is being passed to this direct function, this lambda, this anonymous function. All right, so the array comes in as a single parameter, and the parameter, by the way, is, I don't know why it's W. I think it should be X.
What, the little squiggly W that you're talking about?
Yeah, oh no, that's right. BQN. I noticed this BQN and APL are backwards. So when you have one argument to a function, this W omega, it's actually called omega in Greek, but it looks like a little W. This is whatever argument gets passed into this function. So args, W is that, right? W is everywhere args appears. Okay, so the first thing it does is it says -1.
I see. Okay.
So -1 concatenate, add it to the end of the array.
All right.
So, well, actually, what it does is it says -1 concatenate to W. So args comes into W, and then it concatenates -1 to the end of it. That's all it does.
Does that mean that it adds another element to it?
Yes. So we now have the arguments with -1 added to the end of it. And it'll make sense later why I do that. Then this downward arrow is drop. And this is saying, of this array, this list of things, I'm going to drop the first number of elements that the expression on the left tells me to drop. So I'm editing this list, right? I've got this list of arguments, but I don't want any of the arguments in the beginning up to where a double dash occurs. And this is unique to GNU APL. GNU APL says when you invoke GNU APL as a script, In fact, I'm going to show you, let me show you the script that we use to invoke it. Okay, so I call APL, -s is silent. I don't want it to echo anything. I want it to just execute it as a script. This is the file. And then the -- is used to say, okay, the arguments that you want to pass to your actual program, you have to put after -- everything before that. These are arguments to GNU APL itself. But when I come into the program, I'm going to get an entire array of all of these. So I'm going to see the dash.
That was my next question.
Yeah.
So in this particular case, using GNU APL, which is unlike other scripting languages, where you will run the scripting engine and pass in its parameters, and then pass in your script, and then everything after that will be arguments that are passed into the script. That's different here, where you're actually going to get the entire set of arguments that were passed to the APL command. Is that what you're saying?
Yeah, and you can see that on the left here. What I just did is I punched in what quad arg would do when I'm using it in the interactive environment, and it's showing me the first argument was what I called GNU APL.
Right.
So if I wanted to pass my own arguments when I run it, which is what's happening here, actually, let me go out. And I think we can use the interpreter here to see each thing. So if I say APL and I say blah, blah, it's going to go, oh, I don't know what the hell blah, blah arguments are. It's going to get pissed off. It says, no, I don't know what those are. But what if I say -version? Let's say -version, because that's valid, -- version, right? Okay, that's fine. And then I say -- well, version kicks it out. But let's say I say -- and then I go blah, blah. It's like, okay, I'm in.
Now you're in the interpreter.
Now when I say args, see,
it's going to give you all of the, okay, that's really interesting.
So what I want is I want to ignore everything up to the -- right? That's just going to get in my way. That's irrelevant to this program. So just like in C, I started from argv1 because argv0 is the invocation of the main, right? It's the invocation of C. The actual arguments that the user is passing start at argv1. In here, the actual arguments start wherever it follows a -- So there could be any number of arguments before the -- and I want to ignore all of those. So I have to scan this array, and I want to drop out everything from the -- before, so that the first argument is that countdown.
What is the little the tall sort of L with a short base at the front of that? Because if I remember right, with APL, there were a great deal of things you could do with arrays in a single line.
Yes.
And so is that construction that we're seeing there saying something to the effect of find everything up to -- and then take the first argument after -- Is that what that's doing? Something along those lines?
So you can see I actually just entered the entire line here on the left, and you can see how it parsed out exactly what I wanted. It gave me only the first argument following the -- and nothing else, which is what I'm trying to get. C is whatever you typed in as the countdown on the command line. It's ignoring any subsequent parameters. I don't care if you entered other parameters. I only care about the first one. But you asked the question specifically, what was the tall L? This is floor, also known as minimum. And what I'm going to do is I'm going to actually walk through what it looks like if we don't use any of these. So let's go with, we just do the adding the -1. Actually, oh gosh, I guess I can't undo that. Okay, so we're gonna walk through this one at a time so we can kind of see what's going on here. Okay, so that was, oh no, it didn't concatenate. Let's do this again. Okay, so the first thing that we do, as I already explained, is we just append -1. We get that, right?
Do we have -1?
We append it. That's what the first part did, right? So it just took the original arguments and appended -1. That's what. Remember, we're reading right to left.
Oh, okay, I see that now. The negative is it's an underscore of the previous line.
Now, if I'm going to drop, now looking at what I'm looking at, what I really want to do is I want to drop the first two of these, right? So let's put in a 2.
Mm-hmm.
But I don't know, but I know that looking at it that it's 2. So how do I find out that it's 2? Well,
Which is what the floor thing is.
Well, the floor is actually a much more complicated expression. The more important piece of this is, let me see if I can back this all the way up. What I want to, I can't undo. I wish I could undo. I have to retype this. Sorry, it's going to give me a syntax error. All right. Let's get rid of all of this and do it's a complicated.
Well, listen, unfortunately, I've only got about 10 more minutes, so I don't want to.
Are we already down to an hour? I guess it's going to take too long to go through all of this.
Well, I don't think I didn't really want to necessarily go through all, but I did want to talk a little bit about how one line on the APL is doing so much of what's and what those symbols really mean, because that really gives you a really good understanding of these sort of English language based program scripts and this more of a symbolic approach. Can you bring the BQN back up?
Yeah, I'm doing it right now.
And then here on the right, you see where BQN is almost like a compromise between the two, where you can have more of the English base, a little bit easier for someone to read if they really don't have a background at all in symbolic language. And by the way, I just want to make a note here: in the future, any of the symbolic languages that we want to look at, you're going to be responsible for, because I couldn't have done this in a week. I trying to go back into APL and remember what all these symbols were and what they meant. That would have taken a lot more time.
In fairness, this took me 2 weeks.
Okay.
Well, it took me 1.5 weeks to do the APL, and it took me 2 days to do the BQN, or the 1 day to do the BQN. But you can see the BQN was so similar. This first line does a lot of work, because you can see the C program didn't have to. The C program was able to just say, "Give me the first argument." But the only way to get an argument from GNU was it's only going to give you the array, so it had to be stripped down and broken out and parsed. Otherwise, I wouldn't need this complex expression. But I had to scan it.
The complexity, and that is something that really shows you. Like, for example, this is a problem you didn't have to do PHP, but in here you were bringing in arguments for a whole argument list, which was really comprised of arguments for 2 different commands, one being the APL command itself, and the second being the script that you're passing into the APL. So this additional feature was necessary and could all be done in roughly about 30 characters, it looks like.
Yeah.
And that's a pretty significant difference, and pretty endemic to exactly what the difference is with APL and some of these other. You're going to be able to do a great deal more in APL, in one line that you do C, which you can already do a lot of things in C in one line, or anything based on the C lexer. And the other one was, and I mentioned this a moment, to my knowledge, that APL is very much an array-based language. In other words, it seems, if I remember right, wasn't its primary design to be able to manipulate arrays? There's a lot of functionality behind manipulating arrays.
That is the central focus of this language. In fact, that's why it's in this entire category called array languages. An array cast are these group of these brilliant guys who discuss entirely array languages, and APL comes up more often than just about anything else, because it is the progenitor, or the quintessential original array language, which there's a few more, BQN being one of them, J being the next generation. There's other ones out there as well. Even a language like Julia and MATLAB are starting to accommodate arrays, but they're not initially designed for arrays. APL is designed for arrays. Everything is about arrays. It's like your main data type is an array. All your strings are arrays. Everything's an array. That is the central focus.
That first line of your get count function there is a good example of how that language is built to more easily manipulate arrays, because you can do a great deal in that with just a single line and a few special characters.
And again, in fairness to GNU APL, because it doesn't provide the way to say, give me the first user passed argument, this has to do more work than either of these other examples, because the other examples have that available. The one on the left, you literally just say, give me the first argument the user passed, and it's already there. The one on the right has a simpler way of pulling it apart. But what's interesting is when you look at the other lines of code, for example, the converting it to a number, this conversion to a number, which is taken care of by calling built-in functions in C, stir to L, scanf with the parentheses D to do the conversion. Right, this is code sitting inside of the library of C, probably written in assembler or C itself, doing a bunch of work to compare characters and see if they're digits and see if there's embedded spaces and making sure it can format. I had to actually write that directly in APL because GNU APL does not provide a built-in convert it to number function. But because a string number is an array of characters, it wasn't hard to be able to write a simple expression that does the conversion. So if we were to see the C code for stir to L, we'd see a lot more lines of code on the left here, right, if I didn't use a built-in function. But in APL, I mean, look at how short it is. It literally just says, given the string you passed me, C.
It looks like each element of the array, the string array, has to be a member of the 0 to 9 set of characters.
Yeah, this expression literally says, are all the characters in the string digits? It does a reduce, it does a scan, it scans through all of these. It says, is it an element of 0 through 9? Anytime it's not an element, that's going to produce a 0. You get an array of zeros and ones, and if there are any zeros in that array, this multiplied by the reduction would produce a 0. So in other words, this is only valid if the resulting array here is all ones. The resulting array here is all ones. You get a 1. This is an if statement. It says if it's, I don't know why it's inverted here. It should basically say if 1. Yeah, if it's 1, go to valid. So this just checks for validity. This doesn't do the conversion. And then the conversion down here simply takes each character. Now it knows every character is a digit, so it can safely convert the characters because it already knows.
So you're actually taking. So what is the? Is there something that is converting it to a number type? Is that what this UCS is?
UCS is a GNU APL function. It says, give me the Unicode value of this character. So this takes each character and says, give me the Unicode value, subtract from it the Unicode value of 0. That'll give me an integer number that is 0 through 9. Gives me integer value 0 through 9. If you look at the BQN code, it does the same thing right here.
And the BQN code is a little bit more readable.
Because it doesn't need the UCS. Like, I wonder, I might actually be able to just say W minus 0, just like that. That might have worked. I'm not sure. But I think I could do just that. And now it matches. Because I'm just... BQN, if you look at the spec, it says this is completely valid. If you take a character and you a digit character and you subtract the digit 0 from it, you will get an integer of the value of that character. I think in GNU APL I had to use the Unicode thing, but let's see what happens if I'm going to save this and run it and see if it works. I think I could shorten that up. 12. No, it doesn't like it. So the GNU APL said, no, you've got to use this converting to a UCS code, then you can subtract the values. But BQN says, no, this is totally valid. This is the way that you actually know what a digit is you do it just simply by that. But the rest of it is exactly the same. The rest of it says, for every one of these digits, do a reduction. And what a reduction takes an array and does essentially a for each on the array and accumulates a value based on the operation on the left. So this says for every digit, take the accumulator, multiply it by 10 and add the digit, right? And so that's how you get a sequence of digits into an actual number. This does exactly the same thing. So a little bit different
Okay.
notation, but it's the same operation. And you can see,
Okay. We only have a couple more minutes,
well,
so
we're almost at
I'd
the end.
like
I mean,
to.
that's pretty much it, right? So
Well,
you,
I'd just like to summarize in looking at the APL and the BQN compared to the C. Would we say that this meets our criteria for the bye bye hello world concept, which is I'm a new developer to this language, and has it now given me a reasonable um, list of what this language can do for me based on a few basic requirements like we have designed for this particular example? How does it meet that well enough?
well, I think you're the best person to answer that since you're saying you don't remember APL and you don't know BQN.
That's a really good point. Well, for me, yes, it is. Okay, because I mean, and that's really the question. Is because for me, it is. I have some familiarity with it, and for the person who comes behind me who has not, it really depends on their approach, right? I mean, I think anybody who comes, especially from some English-based language, into it is going to go, I'm not even remotely going to use this unless somebody's got a gun to my head. Okay. That's probably going to be the attitude of any of the young developers that we have today that are coming to this language for the first time. Anybody who has a mathematics background or an engineering background, they might be much more friendly to something like that because of the abbreviated syntax and the fact that we can do so much with so little in those languages. That would be my evaluation. It would certainly be basic. If I had to work in this language, then I would want to take full advantage of all of those things that code.
Ooh.
And for anybody who's working in a extremely resource limited environment, where literally the size of the script might matter, which you see almost nowhere these days, then it would have value to them. And I think but I do think it does describe those basic functions we are saying are necessary with Bye Bye Hello World. What do you think?
Well, it's short. It's, you
Mhm.
almost less than a page. It's smaller than the C. So I would hope it's not overwhelming. It does show a lot of the symbols and glyphs and array operations within it. Um, I I think it's pretty good. I think it meets the
Yeah.
criteria. The only thing I
And I
would
really
say,
like I really like that you did it in BQN as well, because especially if someone was for the first time, seeing them side by side would really help, I think, make that transition, especially looking at the BQN.
well, one of the things that's interesting is this is not the typical use case for APL. It's not.
Right.
It's. In fact, it was a good challenge for it because our Bye Bye Hello World is mostly an I/O program. It's an I/O program.
Right.
It's output, input, output, and it's an interactive program in that sense. Mostly when you see people do examples of array languages, they're showing you examples of sophisticated calculations over matrices and arrays and complex
Right.
groups of data, not an interactive session. Now, fortunately, since APL was designed as an interactive environment, it does have the quote cod to put out. It does have the quad to
Right.
take
Right.
input. On the BQN side, you can see there's an input and there's an output and there's a formatting. There's even a delay. There's a delay on both sides. DL is the sleep over here. Delay is the
Sure.
sleep over here. So I kind of got lucky. I was a little worried that when we went down this road to be like, oh my God, it's not going to have the IO stuff and the concurrency stuff necessary for even the simple spec that we've created. But this gives us a good, I think this validates our idea because it's saying we've pushed against it by saying, yeah, you have to take input, you have to delay, you have to sleep
Yeah.
for a little while. Is this language capable of that? Can I make this an interactive thing? And the answer is, well, except for this one shortcoming on this side where I'm not echoing input, I've got to figure out how to do that. And then on the BQN side, there were two shortcomings, which is the new lines aren't getting suppressed. So when you run the BQN version, it echoes, but it puts these new lines in. And so you can
So
see
in essence, yes, this really does meet the challenge,
yeah,
particular Bye Bye Hello World application.
I think
And that's
so.
going to be the end of what we can do today. So for those that are watching, we're going to do a couple of the things that we've talked about, and then please look at those if you have the time. And look for us again, not next week, but the week after for an evaluation of F sharp.
Yeah, you got 2 weeks.
Yeah.
All right. I wish
All
you
right,
all the best of luck.
I've really got to go. So
Okay.
let's talk a little bit later this week.
All right. Next time.
I'll
Bye
see you
bye.
later.